nanoscale, and then you flow over a gas. Here we have two different kinds of inks. Each one is made of a solvent and some nanomaterials. So these are carbon nanotubes. We've been developing a technology that allows us to use a couple of simple inks in order to turn cotton into a high throughput bacteria filtering device. Yeah, so we're just going to submerge the cloth in the nanotubes, and you'll see that the
Is it called ink just because it happens to be a dark color, or?
So we fabric on one side and to this copper mesh on the other side. Okay, dyed black, and it's also now electrically conductive. Now, if we were normally making a filter, I'd actually take this. So other people in my lab have been working on trying to make cotton conductive for a variety of other purposes, for instance, batteries and that kind of work. And so we had this idea a couple years ago that if we could somehow combine silver nanowires, which are fundamentally antibacterial, in an intimate way with water, mix it at a very small scale, and then apply a voltage to the entire thing, we might be able to kill bacteria at an enhanced rate. I mean, the idea is very simple. We almost wanted to make a nanoscale bug zapper that would just be killing ecoli. So. Okay, let's take a little bit of the pipette, and then we can just kind of drip the nanowires on. Now you'll see that this one has silver nanowires only, no carbon nanotubes. You can see it's much lighter. It's almost a gray.
It's neither one of our main projects.
Oh, okay.
And so it was kind of a side project for the two of us that we took on.
Colonies, so that gives us a percentage of bacteria killed if we know how many bacteria we put through the filter in the first place.
It's already zooming so much you don't see the whole cotton fiber. The cotton fiber is scaled by the where the filter is and sitting inside a funnel, and this carbon nanotube. It's very easy to use nanotube to make the cotton conducting, the textile conducting. So we use nanotube, and then silver come along because we want to use silver for another function. Silver intrinsically is antibacterial, so if you put silver nanowire into the filter, and you don't need to do anything, and the bacteria cannot grow onto these filters. So eventually we have two functions: make the filter conducting, and make the filter antibacterial without even applying a voltage. Carbon nanotube is just very flexible and cover everywhere. Silver nanowire, a little bit longer, a little bit bigger, but still small enough. When we talk about low cost right here of these filters, and it can certainly reach the potential low cost for the developing countries. I think the biggest saving come later is the amount of energy we use for water filtration. Use our filters, it's much smaller than the existing filters. That's where you save a lot of money. Yeah.
Connected to an alligator clip, and that's how we're going to apply an electrical voltage to it. Okay, so we're going to apply a voltage between the copper and the regular device. And there are two important things to note here. First off, there's no
All it's going through is that mesh right there?
No, it's going through because you can see the fabric's in the funnel. Anyway, so it's going pretty fast, much faster than a typical pressure-driven filtration system would. The internal diameter of this funnel is really quite small. It really is coming out quite rapidly. So, and the energy required is somewhat less than it would take to run a mechanically